Hello, boys and girls. Welcome back to another edition of Crush Lusher. All right, so here is the very last thing we need to know in terms of new material for the whole year. Oh, yeah. So we're finally there at the very end. After this, we're just going to review. All right, check it out. So write this down on the top. Volumes of Revolution, Part 3, revolving with respect to Y. Okay, so we've done in respect of X, we've done the donuts, we've done the discs, we've done all that stuff. So now let's put it all together, shall we? Okay, everything that we've been learning about volume so far can apply just as easily when we integrate with respect to y. Okay, so here's the first one. Write this down, pause the video. Region R is defined as the area in the first quadrant bounded by y equals 2x plus 2, y equals 0, and x equals 0. So you got to do A, B, C, and D. So first we're going to do A and B. Find the area of the region R. Then we're going to R is the base of a solid made up of square cross sections perpendicular to the y-axis. Find the volume of this solid. Okay. Then after that, we're going to do some revolutions. So all this A, B, C, D requires this information. All right, so let's go to our notes. Here we go. So first things first, we have to draw a picture. Very important. Draw a picture. Find the area of the region R. So y equals negative 2x plus 2. So that means that 2 is my y-intercept. Then you go down 2 over 1, because that's my slope, right? So there is your area right here. And then it's y equals 0 and x equals 0. So that means that this first quadrant area, that's what we're looking for. And this is 1 right here, because you go down 2 over 1 for their slope. Okay. So the area of the region is between 0 and 2. 0 and 1, my bad. 0 and 1 of top minus bottom. And this is just the area under the curve. So that's going to be negative 2x plus 2 dx. Got it. Now, what if we want to do this in terms of y? Well, in terms of y, which is what we're doing today, so y equals negative 2x plus 2. So all I'm going to do is I'm going to solve for x to get my inverse. So minus 2, y minus 2 equals negative 2x divided by negative 2. Negative divided by negative is positive 1. And this is y divided by negative 2, which is negative 1/2 y, you could say. So 1 minus 1/2 y equals x. So another way you could express it and get the same answer, remember when, is the integral between 0 and 2, if you're doing respect of y, of 1 minus 1/2 y dy. So both of these would yield the same answer. Okay, so now we're going to use this part right here for this coming up now. So R is the base of a solid made up of square cross sections. So out of here are coming squares. So squares are coming out of this. Squares are coming out. Sorry, it's taking a little while to adjust and focus. So that would mean that a square cross section is going out. So this is dy because we're the cross sections are perpendicular to the y-axis right here. So here's the y-axis perpendicular would be this way. And so the squares are coming out actually this way. So all infinite amount of squares, so they're coming out like that. And so this is dy, which is this distance right here. So this is dy. And this part right here, and this part right here, the squares are the same. And so this is what we did before, the inverse, 1 minus 1/2 y. Or y over 2, you could say 1 minus y over 2. If you want, same thing. Okay, so since it's a square, that would mean that this and this side are the same. So this is 1 minus y over 2. And so the volume of a slice is going to be length times width times height. So that's going to be 1 minus y over 2 times 1 minus y over 2 times dy. So now we have our full volume. So that's between 0 and what's that again? Oh yeah, that's 2, because we are having an infinite amount of squares coming out from 0 on the y to 2 on the y. That's how we have to look at it if we're doing it in terms of y with respect to y. So 0 and 2 of 1 minus y over 2 squared times itself dy. Cool. Equals. And then plug that in a calculator to get what you get. Okay, cool. Keep it going. Doing good. All right. Next one. Find the volume of the solid created if region R is rotated around the y-axis. Okay, it's the same thing. So picture, picture, picture. Na 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 na. So here's what we had before. This is 2. This is 1, and we're revolving this around the y-axis. Like this. So we get a little cone shape. Get a little cone shape. So that would mean that we can draw a little slicey slice. So this is dy. And there's no hole in this one, since this is going to be a solid disc shape. So I just we need one radius. And the radius is going to be on this side, because this is the area. So it's going to be this line minus 0, which is just this line, right? So that's 1 minus y over 2, or 1 minus 1/2 y. And so the volume of a slice is pi r squared dy, which is pi radius squared dy. Finally, we need to write our full volume of this whole cone shape. So we have an infinite amount of slices between 0 and 2, very, 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 very small, of pi 1 minus y over 2 squared dy. Done. Cool. Alright, let's keep it going. Now here's a more difficult one. Part D is always more difficult. D for difficult. Let's see if we got it. Find the volume of the solid created if region R is revolved around the vertical line x equals 3. Okay, picture important. Picture important. Let's do it. So here we go. This is 2. This is 1. Vertical line x equals 3 would be here. Drawn a dotted because that's going to be where I am going to reflect across. Okay, so make sure you draw a proper reflection. And so this is the area we're going to rotate. So it's going to go around here. So this is going to be here's my mirror image. And so it's going to revolve like this. So there's outside to outside, and then inside to inside. You have a little holage right there. So outside to outside, like that. Okay. So draw a slice like this. Okay. So now you really have to think. So this is where we have our original area. Okay, so everything goes from there. So this means that here's the big R and here's the small r. Okay, we need to cut out. So the big R is 0. This is the top. Sorry, we can look at it this way. So this is the top. If we turn it this way, so the big R would be this is the top and this is the bottom here. So this is the top, which is x equals 3. The bottom is x equals 0. Because when I draw that, like that, so this is going to be the top. So it's this minus this. So that's going to be 3 minus nothing. Now my little r, if I turn it this way again, always turn your paper, that's going to be 3, and then it goes to this diagonal line here. So it's 3 to the diagonal line, and so that's going to be 3 minus, parentheses, 1 minus y over 2. There we go. Now, volume is dy. Volume of a slice is going to be pi, big circle, which would be 3 squared, minus pi, small circle, 3 minus 1 minus y over 2, squared, all squared dy. So it's the big circle, pi r squared, minus the small circle, pi r squared. And, oh sorry, this isn't squared right here, my bad. So it's top minus bottom, all squared, dy. Okay. So the volume of the whole shape right here is going to be the integral between 0 and 2, still, 0 and 2, of pi 9 times 9, you can do 9 pi if you want, minus pi times 3, you can simplify that if you want, you don't have to, 1 minus y over 2 squared dy. Oh, done. There we go. Okay, so I'm going to do one more, but I might run out of time on this video. So I'm going to do part 2 for the second video coming right up, okay? Nice job. Check out the second video right now.